Assalamu alaikum. Firstly, I introduce myself. My name is Rashidujaman Shakil. Today, I'm going to talking about the binary search tree insertion. So, let's get started. In this slide, I mentioned the definition of binary tree and the difference between binary tree and a general tree. Firstly, a binary tree is a tree which each node contains at most two child nodes. But when you can construct a general tree, they have no limitation of the child nodes. It can be possible to contain two or multiple nodes. If we look in the slide from the left side, here I mentioned a general tree. The root node already contain four multiple child nodes. That means it's already break down the binary tree rules. If you focus on the right side in the slide, here I mention about a binary tree, and I can see the root node contain at most two child nodes, and every parent node also contain two at most two child nodes. So that is called the binary tree. If I summarize this difference between binary tree and general tree, that will be in a general tree they have no limitation, but if you construct a binary tree, they have limitation of the child nodes. I think it is clear about the difference of binary tree and the general tree. In this slide, I introduce of trees parameter. In a tree have more of component like the parent node, child node, and the relationship between two child node is called the sibling. And we can demonstrate a root into two distinct portions, like as the left hand side is called the left subtree and the right hand side is called the right subtree. I am clearly trying to visualize into two distinct color. That means the green color I mentioned for the left subtree and the red color circle I mentioned for the right subtree. And in this tree, my root node is A, and from the tree you can evaluate it, the number of level. If you want to count down the number of level, you must to evaluate the highest length of a tree. From this slide, for my root, the highest length will be 4 because the countdown starts from A and the last child node is age. So the length is 4 and the level will be 4 minus 1, 3. But remember that the level will count down from 0 indexes. So my level will be 0, 1, 2, and 3. In this slide, I'm talking about a binary search tree insertion. And I already mentioned a question. And the question is the construct a binary search tree by inserting the following numbers from left to right. And here I can see some numbers randomly. I recommended that if you want to solve this problem, you must have a basic concept about root. So particularly, the left subtree always contain the lowest value rather than the root node, as well as the right subtree always contain the highest greater value from the root node. And if you want to solve this problem, you must to follow this conditional statement. Like as if your target value is greater than the root value, it will be positioned on the right side of the root node. Same as the target, if your target value is less than the root node, that means it will be positioned left side on the root node. And this condition is repeated one and one. So my first step is to identify the root node. If I focus on the question, it is clearly mentioned that the constructed binary search tree is start from left to right. So my root node is 8. Now my target value is 5. If I insert 5 into the tree, I must follow the conditional statement. At the time, my root node is 8 and my target value is 5. So my target value is less than the root node. So it will be positioned on the left side. Now my target value is 10 and my root value is 8. So 10 is greater than 8. So it will be positioned on the right side. Now my target value is 16. So my root value and my root value is 8. If I check the condition, 16 is greater than 8. So it will be positioned on the right side. That is already positioned the right side of the root node 8. But when we inserted 16, we see that there already available a node that is 10, and now 10 will be the parent node of 16. If I inserted 16, I must to follow again the conditional statement between the 10 and 16. So 16 is greater than 10, so it will be positioned on the right side of 10. As well as I inserted 18, 25. Now my target value is 9. If I insert 9 into the tree, I must to check the conditional statement. My root value is 8 and the target value is 9. So 9 is greater than 8. And now I'm in 10. And I also check up the conditional statement again. And 9 is less than 10. So it will be positioned on the left side of the 10. As well as I inserted 15 and 13. Now my target value is 7 and my root value was 8. So 7 is less than the 8. So it will be positioned on the left side that I already inserted. But now I'm in 5. So I need to check out the conditional statement again. And if I check the condition between 5 and 7, that means 5 is less than 7. So 7 will be positioned on the right side. For 17, the root value is 8 and my target value is 17. So 17 is greater than 8. It will be positioned on the right side, that already positioned on the right side. But I must to check up the conditional statement for 10, 16 and 18. When I am in 18, I also see that 17 is less than 18. So it will be positioned on the left side. It is my full constructed binary search tree. Now anyone tell you to find out the level. I already explained how you can evaluate the level of a tree. Your first step to count down the highest length of a tree. I recommended you to count down the tree from the root node and find out the last child node. In this tree, my root node is 8 and my last child node is 25. So my highest length is start from 8 to 25. So my highest length is 5 and the level will be 5 minus 1, that means 4. And I already mentioned the level countdown start from 0 indexes. So 8 so 8 will under the 0 level, 10 under the 1, 16, 18 and 25, as well as 25 under the level of 4. I hope you will get a clear concept of a binary insertion and how you can evaluate the level of a tree. Thank you so much for watching my video presentation. Stay safe, stay well, Allah Hafiz.